Hariam children. So, welcome to the Amarsa's second video, that is your class 9 subject mathematics. This is again the same thing in our number system. In our first video, I said about or I explained about the rational numbers only. And in the second part of this video, we will explore the following concept, that means decimal expansion of a real number, representing any real number on number line. The operation of a real number is very much important, and a lot of exponents, that is you already read in class 8, only just a glimpse of idea I will give. So again recall your memory. We told that any number which in the form of a p upon q, where both p and q are integers and q not equals to 0, is a rational number. And the number which is not rational is known as irrational number. What again we understood by according to the decimal expansion definition. If a number is terminate, whose decimal expansion is terminate, we are telling they are rational. So another things we have to remember, when any numbers are coming repeatedly or recurring decimal also, that we can convert into the p upon q form. So today our first concept is, if any recurring number is there, how we can convert them in the form of p upon q. For example, convert 0.13 bar. That means that number 13 is repeatedly at infinite times. You can write this one also like this: 1.13, 13, 13. They are a recurring number or recurring decimal. Recurring means the numbers which are repeated. Another example, 0.3 bar. That means 0.3 is repeated up to infinite. So this type of a number, how we could convert in the p upon q means how to form in the fractional form or in the rational form. I am so giving one example. For example, convert 0.13 bar in p by q form. P upon q form. For that, you have to take, just follow my steps how I am doing. Let x is equal to 0.1313. That is equation number 1. Multiplying 10 on both the sides, we get 10x is equal to, decimal move one place, 1.313 dot equation 2, multiplying 10 on both sides, we get again multiply 10 on both the sides, we get 13.1313 dot. So like this, should I multiply 10 on the both of the sides? I will continue, or at any junction I will stop my multiplying the number. That is the big question. So where I should stop my multiplying? Just tricks you have to see. When I am multiplying, I am seeing my the right hand side of the decimal part. For example, see, x is equal to 0.1313, like this going on. 10 I multiply, I got 1.313. Just look this part only, then again 3 and this part. I got the similarity from which equation and which equation? Now equation 1 and equation 3. What relation or what similarity I got here? So after decimal, which numbers are there? 0.1313. Equation 3 also, the same numbers are repeating here. 0.131, 13.13 and 13. So on that cases, you stop multiplying 10. Go on multiplying 10 on the place where you are getting the numbers of after decimals are same. You just multiplying, then with the two equations whose decimal parts are equal, subtract two equations. That means now I will subtract equation 3 with the equation 1. So what I got? These two equations I will subtract. So 100x minus x is equal to. So when I am multiplying, what I am getting here? 100x minus x, that I know 99x is equal to, this part are given is, you got 13 minus 0, that equals to 13. So x equals to 13 upon 99. That means the recurring number I converted into the P upon Q form. So this is how we will solve, or any recurring number we can convert in the P upon Q form. Another example also I will give you. For example, convert 0.123, this 3 bar only, in P upon Q. Same method, let x is equal to 0.123, bar means 3 is repeating, equation 1, multiplying 10 on both the side we get, move 1.2333 bar 2, after decimal they are not equal, keep on multiplying, 100x equals to 12.333 question. So any one of them they are not similar, again keep on multiplying, 123.333 4. Now stop multiplying the 10. Because what? In the equation 3 and the equation 4 I got. What got? After decimal, they both are equal. So that will be subtracted. That means 1000x minus 100x is equal to 123.33 minus 12.333. What your answer? 1000 minus 100, 900x is equal to, after decimals they over, the finished. So 123 minus 12, 900x is equal to 101. Then x is equal to 11 by 900.
That's okay.
So this is clear how I converted 0.123, 3 bar only in P upon Q form. This is one of the most important concepts of this chapter. So next concept is how to visualize any real number on the number line. The real number, that means rational number, that representation of any rational number we already did in class 8. Only irrational numbers, or the repeating that one, I will show how they will be visualizing on the number. For example, represent 4.6 root over on number. Is it clear? Representing irrational number on the number line. For that, what you have to do? You just take the 4.6 with the help of a ruler on your notebook. That is 4.6. Name as O and A. So from A to B, that is compulsory 1 centimeter. 1 centimeter only. That means any number, root over n. For example, root over n represent on the number line. So what you have to do? Take n centimeter on the number line from A to B, 1 centimeter. Next, this OB, you bisect under the middle point. I know how to bisect a line segment. I got this one. With the center of D, for example, this is named as C. No, C. With the center of a C, with the equal radius OC and OB, you make a semicircle here. Is that clear? So at the point A, when you are doing any perpendicular, and this is your root over 4.6. Just extend this line, just measure this line, and so on the number line. So on the number line, measure this one with the help of ruler and compass, and so on the number line by its projection. First, again one time repeating, the representing of 4.6 root over on the number line. For that again, whatever it is given, you take first 4.6, again extended 1 centimeter, bisect that line segment, got the center with the radius of OC or OB, make a semicircle. At the point of A, you are drawing a perpendicular. At what point they will be intersect the semicircle, that name as D. So AB is your required question, required answer. That take the measurement and make a semicircle. So here you will get that E, that is equal to root 2 over 4.6. I hope you understood this concept also. And the third one, what I told, the operation of an irrational number, it is very much important. That means the operation of addition, subtraction, multiplication and division of irrational number we have to do. For the addition and subtraction, you have to see who are the like term first. For example, root 3, 2 root 3, 3 root 2 and 5 1. So this among the 5 numbers, if I say that root 3 and 2 root 3, they are like term because their irrational part are same and they can be added and subtracted only. For example, root 3 plus 2 root 3 if you are taking, then adding, you take root 3 as a common, the coefficient 1 plus 2, your answer is 3 root 3 only. Only those who have like terms, means those irrational parts are same, they can add it and subtract it. And what about multiplication and division, I will say. Same manner, if you subtract another number, first look their like term first, then go further. For example, 5 root 2 minus 11 root 2. Yes, their irrational part are same, they are like term. Take root 2 as common, 5 minus 11, your answer is minus 6 root 2. What about multiplication? Same question, 5 root 2 multiplied by 6 root 2 first. Take this one. So first multiply rational number with rational. So 5 6 that multiply. Again irrational part. Root 2. What answer I got? 30 multiplied by. So when root 2 into root 2, you are getting root 4, your simple answer is 2. So your answer is 60. Just change the number here. If I am giving here 3, so what is your answer? 3, but this is not 2, this is root 6. Your answer is 30 root 6. So in the multiplication, rational with irrational multiply, irrational and irrational multiply, and then you suggest your answer. Then what about the division? In the division, the most important part is how to rationalize the denominator. The rationalizing denominator. For example, 1 upon 2 minus root 3, and in the denominator we have irrational number, we have to rationalize it. So when we are rationalizing the irrational number part, so irrational numbers are given on the denominator of a rational fraction, we have to rationalize it. So how to rationalize it? Just multiply its conjugate. Conjugate means what? The same numbers with opposite side. If I have 2 minus root 3, I have to multiply 2 plus root 3 on both the numerator and denominator. Then what answer I am getting here? 1 multiplied with 2 plus root 3, that is 2 plus root 3 only. So when I am getting 2 minus root 3 and 2 plus root 3, I am using an algebraic identity. I know that a minus b when multiplied by a plus b, my answer is a square minus b square. So the same algebraic identity I will use here. So I got 2 square minus root 3 square. Then my answer is 2 plus root 3 by 2 square is 4 minus root 3 square. Now only in multiplication I told you, when the same number are repeatedly multiplied, root 3 square means 3 square 9 root over 3. Please remember for shortcut, root 2 into root 2 that equals to 2. Root 3 multiplied by root 3 is equal to 3. Root 5 multiplied by root 5, that answer 5 itself. This is how root 5 into root 5 is root 25. The square root of 25 is 5. Root 3 into root 3, that is root 9. So square root of 9 is 3. So similarly that is 3. So 2 plus root 3 by 1. Now see here, the denominator before or previously it was a irrational number. Now that irrational number I converted into the rational number without changing its values. That means that is the most important part, how you should rationalize the denominator. Again one can say, if a question is given like this, just look at the denominator, just multiply the conjugate of the number. For example, 2 minus root 3 is given, you just multiply, conjugate means same number with opposite side. 2 minus root 3 is given, multiply 2 plus root 3 upon 2 plus root 3 and go on for the simplification, you will get your answer. And the last concept of this chapter, that is laws of exponent, that is we also read in the class, just revisiting laws of exponent. Laws of exponent. I will just give some laws. First law, a to the power m into a to the power m is equal to a to the power m plus n. That means same base multiply. For example, 2 square 2 to the power 3, 2 there, 2 plus 3 is equal to 2 to the power 5. The second law, divide, I am getting my answer m minus n. Here, when m greater than n, that equals to 2 to the power 6 divided by 2 to the power 5, 2 to the power 6 minus 5, 2 to the power 1. Third one, negative of any power, you can convert into the positive one. For example, 3 to the power minus 2, you cannot keep any negative powers of a power indices, just reciprocal and got your answer. Then fourth one, multiplied repeatedly, your answer is a to the power mn. Example, 2 square and 3 is equal to 2 into 3, 2 to the power 6, and fifth one, n to the power 0, answer is 1. 5 to the power 0 equals to 1. So I hope you understood this total concept of lesson 1, that is real number, what is rational number, what is irrational number, how will you get the rational numbers in between the two numbers, the proving of irrational number by the contradiction method, that is work for you. Then representing rational numbers on the number line, representing irrational number on the number line. Second, operation of irrational number, then laws of exponent. You just see, this is just give the deleted portion of a class 9 and 10. So it will be better for you just download the revised syllabus of a class 9 for the academic year 2020 and 21 and follow the syllabus. So this will be homework. You just do all the homework of lesson 1, that is from lesson 1.1 to 1. Last chapter is which one? 1.6 on your notebook. So when you will submit the notification you will get on that day only you have to submit. So be careful and study very hard at home. Thank you.